Okay, hi everyone. We are really happy to be with you today. And today with Manu, we want to talk to you about the impact of IT on the environment. And about that, you see this picture? It's in Ghana, where all our broken devices end up. Besides being a disaster for the environment, it's also a tragedy for the health of the people living here and working in this garbage dump. But don't worry. Today, we want to give you a deep understanding of why this happened and what can we do as developers. And Emmanuel, can you explain us the truth? How did we get there?
Before going deeper into the details, it's important to know that when we are talking about the impact of industry, it's not just about greenhouse gas emissions. We have to take into account the usage of water, the usage of resources, and also the energy consumption. But today, we will only focus on greenhouse gases emissions due to timing constraints. But the conclusion will be the same for all factors. According to several studies, IT accounts for globally between 3 to 4% of global greenhouse gas emissions. And at the national level in France, it's around 2.5. But these statistics are likely to increase in the next decades and will be 6%. The issue we are facing is the evolution of our usage of IT, the evolution of usage regarding technology. If we have a look to this table, at the same time, we have a number of equipment per user that is decreasing. But globally, the number of users that can access to IT devices increase. So as a conclusion, we can see the number of devices is quite similar between 2050 and 2025. But if we have a look to the IoT devices, it has tripled between 2010 and 2025. As a result, the total number of devices in 2025 will be double if we compare to 2010.
Okay, now let's have a little hands-up game. Who thinks, where does the majority of greenhouse gas emissions occurs? Who thinks it's at the data center level? Raise your hand if you think it's at the data center level. Okay. Who thinks it's at the network level? Okay. And who thinks it's at the user equipment level?
The majority.
Yes. Well, you are right. The answer is that the majority of greenhouse gas emissions occurs at the device level. And here are a few statistics. 60% of greenhouse gas emissions occurs at the user equipment level. This percentage includes the production and the usage. But you must know that the production is a big part of this percentage. And one thing that can explain that is that, for example, for one data center, for one server, there are more than 400 devices. Sorry. We are not here to say that there is nothing to do on the network side and on the data center side, but we must really understand where does the majority of impact occurs.
Okay, there are two reasons for that, but before explaining them, just a little last hands-up game together. Let's count how many digital devices do you have in your home for all your family, wife, husband, kids. And we will do the same exercise together because we are living in the same home. So how many laptops or computers do you have? I have 2 and you have 1. How many smartphones and tablets? Used and unused tablets. So I have 1 old iPad in somewhere. One phone, and you have 3 phones. How many smartwatches do you have? I don't have. You have 2, I think. how many smart TVs and screens. So we have 2 TVs and 2 screens for work. Gaming consoles. We don't have gaming console at all. Connected devices, connected toothbrush, connected washing machine, IoT, home automation items, I don't know. So, I don't know.
No,
we don't have anything else.
Yeah.
Once this is done, just divide this number by the number of adults you have at home. So how many of you have between 0 to 5 items per adults at home?
Good job.
0 to 5, okay. 5 to 10. 5 to 10. 10 to 15. More than 15.
Okay.
Globally, we have 8 devices per person. Now let's focus on the lifespan of a terminal. As you can see here, more than 60% of terminals are replaced in the first 2 years. The good news, however, is that the lifespan is the same whether we buy a new one or a second-hand phone. But the question is, why such a short lifespan? Of course, there is replacement because we lost our phone or the phone is broken. Next, if we set aside the OS not maintained thing and focus on the next number, we have reached now the surprising aspect of software obsolescence, which is about the user perception that their phones doesn't work well, doesn't work as intended. We must ask ourselves what not working well means. We are all developers here, I think. We are all capable of understanding why my phone is not working correctly. Is it due to a network issue, a memory issue, the worst application ever I installed yesterday? I take too much pictures of my kids, so my storage is full. We are capable of that because we have the knowledge. We live in the IT every day. You create mobile apps. I am a web developer. But is everyone capable of that? Is everyone capable of making this analysis? Have you ever experienced a family gathering where you were asked to fix your in-law's phone? Or where your uncle said that for the 3rd time in 3 years, he has replaced his phone just because it was too slow. Then there are replacements simply because the user wants to change their phone, or maybe because the marketing offer was so good.
Okay, now to understand better why producing a new terminal has such a big impact, let's hypothetically disassemble a phone. It consists of a display, a battery, processors, transmitters, emitters, sensors, speaker, microphones, well, lots of things. But can you help us to go even deeper, Manu?
Yeah. You must know that a phone or computer is not just lithium, silicon, or plastic. If we have a look to the periodic table, this is the only time during the presentation I need to read my speaker notes. Sorry for that. For the battery, we need nickel, cobalt, and lithium. For the electronic chips, we need silicon, copper for the cables, aluminum, iron, chrome, nickel for the casings. The most difficult one. Nickel, ruthenium, tin, copper, silver, gold, platinum, antimony, palladium, tantalum, titanium, barium for the electronic boards. Gallium, indium, and again tin for the screen. And finally, neodymium and dysprosium for the speakers.
But to extract all these elements, as some of them are becoming increasingly difficult to mine, we need to excavate more materials. For example, to extract 1 ton of gallium, we need to move 50 tons of rocks and raw materials. And I think this concept has a name in green IT.
Yeah. This concept is called ecological backpack, or MIPS. MIPS for material input per unit service. MIPS is simply the representation of the weight of the rocks we need to excavate compared to the weight of the metals we have in our phone. As you can see, the MIPS varies depending on the device. So for example, here, for a smartphone, we need to excavate 221 kilograms of rocks just for 300 grams of metals inside my Android phone.
But in addition to these environmental issues, there are also other issues that we can mention. For example, here, the use of child labor in mines in Democratic Republic of the Congo.
Or the displacement of people in Germany just because the authorities have decided to destroy completely a village just to help the work of these huge excavators. It brings up political and strategic question. Will we have access to products made in Taiwan if we have a look to the tension they have with China?
Or will there come a day in the future where we have to prioritize the use of metals for our personal digital use or for healthcare? And finally, we are back here in Ghana with the complexity of managing the electronic waste. Okay, we understand that you might feel a little bit overwhelmed now, and that's why we don't want you to leave this keynote without few practical tips to apply directly into your apps.
Before speaking about best practices for developers, let's have a look to what we can do as a user, or your family also. So please share the slides to your family. We must avoid buying new gadgets. We must opt for second-hand phone. We can avoid renewing our devices too often. The good metrics is to keep our phone almost 5 years. We must take care of our devices, and of course, educate people who are not experts in the field. You know the uncle that changes the phone every 2 years? You need to educate these people. And last one, reconsider our digital habits. We all know that we spend too much time on our screen, and this is not good for our well-being. Now, as a developer, what we can do? Few seconds ago, I said that I'm still a web developer. Few years ago, Frédéric Bordage studied how to make websites sustainable, and thanks to that, he has created a repository of best practices. And thanks to this repository, the greenit.fr association was born. In the web ecosystem, we have multiple best practices repository, and the second most used repository is the one created by the DINUM, the French Digital Directorate. But as I said, unfortunately, these two lists of best practices are just web-related. That's why, a few months ago, with Fanny and the support of a collective in Lille called It's on Us, one of the most contributors of the greenit.fr association, Fanny and I decided to adapt this list to mobile development. Sorry. I have a number of times I need to say web during the mobile conference. And today we want to give you these practices.
Okay, before starting to review just a subset of these practices, if we had to resume only these practices with one sentence, it will be, don't be the app that makes your user renew their phone. With that being said, let's move to the 5 areas of action where you can apply concrete practices. The first area of action is at the specification stage. Then we will see after that we can improve the network to reduce the load on it. We will work on performance to have an impact on memory. Then, of course, we will work on storage. And finally, on compatibility. Okay, but Manu, why do we have to work at the specification level?
To answer to that question, let's have a look to the following graph. It shows at which stage of a product lifecycle we have the biggest impact. And as you can see, that is not during implementation or hosting. We have the biggest impact during technical design and functional design. So let's have a look at some best practices so you can understand why the impact can be important. So, the first one is quantify the dimension of your functionality correctly. The dimensions can be, I don't know, the compression rate, the maximum response time for an HTTP request, the number of items to prefetch in a list. The more we do that, the more we avoid overquality. Then, the 2 other next practices are not unusual from a product design point of view. We must optimize the user journey, and we must prefer simple and clean design. And finally, we should remove non-essential features. And let's go deeper to the last one. To the question, are users actively using my features? A study said that more than half of the features are rarely or never used. By applying methods like must do, must have, should have, could have, won't have, as a product lifecycle, product design phase, we can detect non-essential functionalities. And by reducing these functionalities, we reduce the power needed on the infrastructure to host your application or your API. And on the device side, we reduce the storage space we need. Now, Fanny, let's continue with the network category.
Okay, so as developer, we should avoid fetching all our data in resume state. I know that sometimes it's really easy because we are sure that our app reflects our last data state. But when we do that, we call too often the server, and as Manu said, it increased the energy needed for the server side. We should use lazy loading. For example, if in our list we have some images coming from the server, well, if we use a lazy loading, they are loaded just at the right time. We can also, later we will see that we can also do some stuff with lazy loading, as you know, to reduce the memory usage. Of course, we should keep using tools like Glide, like Picasso and Coil to cache images provided by the server. We should definitely build an offline first application. This way, by storing everything on the device, we reduce the number of requests, and again, we reduce the load on the infrastructure to host your API. We should limit analytics tools. Sometimes we had 1, 2, 3 analytics tools. I think I have seen more than 3 analytics tools. 1 is more than enough, and even 0 if you don't use your analytics at all. Think twice about that, because it had a lot of requests, and the app size also is growing with that. And last but not least, we should optimize HTTP requests. And again, let's go deeper into that last one. What can we optimize? First, we can optimize the number of requests. you know, sometimes we call several web services, we combine the data just to match the use case of our apps. Or sometimes there are more data transiting on the network for a web service call that we actually need. Or again, sometimes we call too often a web service. We can also work on content resolution. If we are displaying content on a small part of a screen, it doesn't require full HD content. We should adapt to the display size, to the resolution of the device, as well as to the network connectivity. And finally, we should choose the appropriate format for our media content, for example, because we know that some type of content, some format are smaller than others. And let's focus on images with a concrete example. Here, it's the website of Android makers. We are on the speaker page. And if we open the Chrome DevTools, we see that it loads almost 15 megabytes of resources. And half of these resources are just PNG for the images of the speakers. Let's have a look to Gérard Paligot image. We see here that before, in PNG, he weighed 147 kilobytes. And here we have put his image in Squoosh. It's an online tool that helps you to convert a file into different formats. But you can also do that directly in Android Studio to convert it to WebP. And we see that we gain more than 90% of the size of the image. Now, if we try to measure the impact of this gain to the 64 speakers on this page. Suppose that the image all weight about the same that Gérard. It makes in total 8.6 megabytes, only for the images. Suppose now that we have 10,000 visits on this page. That makes 84 gigabytes of data. Now, thanks to the one-byte model by the Shift project, we can convert and estimate the energy that is needed to produce this data. So first, let's measure the energy consumption on a 4G network. This is the formula, and it makes almost 14 kilowatt-hours. Then we have to add the energy consumption on the data center, and that makes almost 7 kilowatt-hours. And finally, let's set aside the 84 gigabytes of data and measure the energy consumption on the mobile. On average, a mobile consumes 0.11 watt-hour per minute, and let's assume that all our users are spending about 3 minutes on the website. That makes 3.3 kilowatt-hours. So in total, that makes 23.5 kilowatt-hours. Now, it's time to convert that to carbon emission equivalent. And here, we know that the server of the API for this website is hosted in Germany. And sadly, in Germany, for the moment, the energy is still a lot of carbon. So the factor is 8.441. But as a comparison, in France, our factor is like 0.05. So that makes, to display our 64 speaker 10,000 times, 10.3 kilograms of CO2 equivalent.
Okay, but what does it mean, 10 kilograms of CO2 equivalent? If we used a French online tool made by the ADEME community, it's a calculator just to compare kilograms of CO2 equivalent to some human activities. So approximately, the 10 kilograms of CO2 equivalent is similar to watching on a phone, on a 4G connection, 3 hours of streaming per week during 1 year. If we compare with Wi-Fi, the same activity is now 7 hours of streaming. So 4G consumes more energy than Wi-Fi, and this is related to another best practices that was already present in the first greenIT.ifr best practices repository, is to encourage Wi-Fi over 4G. Now let's move to the next category, memory.
Okay, for this section, you will see that it can all be resumed to one subject, performances. And if you follow all the best practices about performances from Google, you might be good. But before jumping to these practices, let's clarify something. Why do we have to preserve the memory? Don't we have devices powerful enough?
Several decades ago, two scientists studied the evolution of efficiency of device. The first one, Jonathan Coomey in 1950, said, the energy efficiency of computing doubles approximately every 18 months. A couple of decades later, in 1995, Nicholas Wirth, the creator of the Pascal programming language, said, the software gets slower more rapidly than hardware becomes faster. So on one hand, we have devices that are becoming increasingly efficient, but on the other hand, our software are getting slower and slower. This is simply because we all develop huge applications without really considering whether our application will work properly on devices that are less powerful than ours. That's why we suggest few best practices, all related to performance. It's not all best practices, and we have to select some of them. We need to limit the complex operation on data provided by the server. We need to avoid SQL queries inside loops. We need to cache objects that are heavy to instantiate and free up resources that are not used anymore. And one item that I don't understand at all as a web developer, you need to improve your composable skippability.
Okay, now what about storage? The main idea is to occupy less space on the user disk. So we should remove unused resources or dependencies, and about dependencies, we should really think twice when we had dependencies just for one usage, because it will make the app bigger. We should minify the code. Really, this one will have a huge impact on your app. And today, if your app is like a simple app and it weighs like more than 100 megaoctet of size, it's really too much. And if you minify your code, of course, it will probably shrink and also remove unused resources. We should store only necessary data. So also before, I told you that we should have an offline-first strategy. We should put on the database only the necessary data. And we should think of deleting the data when they are not useful anymore. For example, if you are developing streaming application where you can download TV shows, probably your user at the end of watching his TV shows offline, it do not want to have it anymore on his device. So we should remove the file at the end. Really have a look at the size of each app on your phone that they takes, and you will really think like, okay, it's crazy. I didn't know that this app was taking 4 giga on my disk. And we should reduce resources and asset size. Applying the same practices for reducing the load on HTTP requests, for example, by choosing the right format, so vectorial images when you can, and when you can't, WebP are working perfectly, and also AVIF work with COIL and is even more compressed for images. For your font, if you really need to include fonts into your apps, TTF files are bigger than downloadable fonts, so think about that as an alternative. And to measure all those efforts, you can just monitor your app size. But app size sometimes can be difficult to understand. What do I have to monitor? Do I have to monitor the APK size, app bundle, of course, app bundle? And Actually, there are 4 metrics that are interesting to measure. The 2 first metrics happen at the network. You will have an impact on the network level. You can monitor the download size, is basically the size taken to download your app on the device. The update size, we should really think and know that when we send an update, it consumes data. And there is a really interesting article about Spotify. They push lots of updates, and they have millions of users, and it has a huge impact. So for them, if they just reduce a little bit the size of the update size, it had a huge impact. The other part is having an impact on storage directly. There is the install size, is basically the size of your app uncompressed, really measure uncompressed size when your user just install the app. And there is the storage size when your application is being used, so it's the install size plus your cache, your database, your images, the files that are downloaded, and so on. So I really advise at first to monitor those 2 last, because you will have more lever to work on that. And last but not least, as you might guess, compatibility. The 2 main best practices are kind of obvious also. You should choose carefully your mean SDK. And sometimes we see like apps that should be available on all devices, but they are not. And for example, you want to use Jetpack Compose. Mean SDK is 21, and it's compatible this way with more than 99% of the device market. Then you should test your app on device with minimal capacity. As developers, we all develop in a perfect world. We have a recent phone, we have a powerful phone, we work on Wi-Fi, but that's not reality. And as a result, it's also indirectly impact the compatibility of our apps. Okay, we didn't have time to go through all the practices and to go into details to all practices, but if you are interested, we have set up these practices on this repository. Later, for the moment, it's still work in progress, so don't hesitate. If you have any question, any suggestion, please add some issues or contact us. And later, this repository will be merged with the greenIT.IFE best practices. Also, if you have any question to talk about accessibility or green IT, please come to see us today at 11:30. And to conclude, if you had to only remember one thing from this keynote, is don't be the app that makes your user renew their phone.
Thanks a lot, and have a nice Android makers.
We can take 5 minutes of questions.